Hello everyone and welcome to this SCIA Engineer version 21.1 webinar. My name is Vladimir Příbramský and it's my privilege to share with you all what new developments are we releasing in this version. During this call or webinar, you are not able to use your microphones to ask questions. However, you can use the questions box in the GoToWebinar application to ask your questions during the presentation, and we are going to get back to your questions either during the webinar or afterwards. Please be aware that this webinar will be recorded and posted on SCIA YouTube channel for any further view or sharing. So what's new in version 21.1? Let me summarize it in multiple topics that I'm going to talk about. I'm going to talk about improvements in analysis and drawing and evaluation of results. I'm also going to have a look at new UI, new user interface of SCIA Engineer that was released in version 21.0 and that was further improved in this version. We are going to have a look at improvements in composite and steel design. Also, improvements in concrete check and with specific of it being applicable for integration member. And last but not least, there is going to be a topic about interoperability. We have a new link with Ideastatica Connection, allowing even more seamless integration of these two tools. Let's also have a look at planned webinars, because this webinar is the first one and some of the topics are going to be tackled by separate webinars. We are going to have design of composite column webinar on 2nd of November, design of concrete members on 3rd of November, and advanced analysis in SCIA Engineer on 9th of November. Additionally, there will be a webinar held about BIM and BIM in SCIA Engineer, and this is also going to cover the Ideastatica connections. Let's jump right in on the analysis and results. We have three topics that we would like to share with you today, and the first one is about 2D data. In version 21.1, in the 64-bit version, we have the possibility of clearly show thicknesses of slabs. So it is something that can be used for as a graphical or tabular export. You can use it together with the engineering report to get really the clear overview about the material used in any structure. We also enhanced result legend so that it is not by default smooth, showing the rainbow, but also, as you can see here on the image, there are discrete values and the user is aware about which plate or which color represents which thickness exactly. Let's have a look how that works. So in SCIA Engineer, let me just here adjust the view. So I have a few different layers on this structure, which is modeled out of 2D elements as being too massive to model by beams. I can run the 2D command thickness of slabs. There are typical settings like filtering based on material or based on layer. So you can use these, and any of these images then can be sent to engineering report for clear documentation of your model. Furthermore, we are able to run the result table command in the action buttons of the check or of the results, and this shows all the data in tabular form. And you can interact with the table by double-clicking on specific lines to see which plate in the 3D scene it represents. Another improvement to analysis and especially results is connection forces. Also in the 32-bit version, we have this possibility, but we extended the workflow and we enable to see more data from this result. So of course, the connection is an entity. It can be defined on any node, and we have results available either as a sum for all connected members or also per member, which we think is an improvement that will make the using of it even more useful. Let's have a look how that works. So here I have a model of a steel structure, as the connection forces are best used for models of 1D members. Here at the bottom you see connection input. I select a node and connection is represented by this axial triad together with a circle. When this is defined, I can run the connection forces result, and again, same settings as for typical results. I am able to show connection forces per disconnection. You can see in the first table there is a total sum. There are zeros because there is equilibrium in that node. So therefore we added the second table, which contains the loads coming from each of the beam into the connection, which then can be used separately to design each aspect of each connected member to the superstructure. Third, about analysis and results, we enable a nonlinearity type cable. This feature allows you to model any cable state or cable-like structure, like here a suspension bridge, and the analysis with cables was improved in 64-bit version in the following way. First, we have a preprocessor, which is analytical tool that shows the deformation of the cable based on some very basic parameters like pre-stressing force or estimated loading on the cable or its self-weight. So this way, we are able to show you the predefined or preprocessed results, which can further help you during the modeling itself. Also, what is new is that between different cables, we are now supporting the connection between them, and this works quite okay in the analysis. Let me show you on a bit smaller model than I had on the picture how that works actually. Here I'm going to use marking menu, which is a new tool how to create things in the new interface. So I create a beam, and on the beam I add the nonlinearity of a type cable. And right away, I am able to assign pre-stressing force and some other properties to it to really see already the curved shape. Now I'm able to just add some other cables, and that would be the vertical ties. I'm able to this way to trim them based on the definition curve of the main cable. Yeah, now by trimming, I will get the connected members to the desired topology. Now I can create, of course, or add the cable type nonlinearity also on these ties, and yeah, I can set the pre-stressing of them as well. While doing so, now you see that the topology is basically finished. The only thing that remains is to connect the dots, connect the nodes on the ties with the main cable, and I'm now able to even adjust the pre-stressing force, and you can see that the connection really works because the structure is acting accordingly. After the calculation, I can just go for results, and in this case, I can show 3D displacement, but of course I can show any results or use any check for this nonlinear combination. So these were cables. I think that for those of you that used this feature even in the past, you really can see that the workflow of inputting the cables were tremendously improved, and it's now much faster than ever before. I actually touched this topic before in the previous video, but there are also improvements in the new user interface. And the first one that I wanted to show you, we call marking menu. It's actually an invisible helper that's available with holding Alt and right mouse button that would actually show on the spot where is your mouse cursor. A special menu would be shown to really allow you the productive modeling with option to also skip the input dialog. This way you can be much more productive during your modeling, and I'm going to show this to you just in a few seconds. The marking menu is populated to enhance the muscle memory. So really these commands that are in the marking menu can be run within fraction of a second instead of few seconds that were needed before. Let me demonstrate how that look. So the marking menu has separate areas based on a topic. So we have structure, load, modification, and also visibility that can hide or hide selected or unselected. If I run the command, I can model right away. And you can see that I didn't need it to be precise on the button, because as the name marking menu implies, it's really only taken into account the direction in which your mouse moves. So if you would just after very short time remember that, of course here the slab is the going down, but slightly to the left, you are really able to remember these commands very quickly, and as I mentioned, to run them within fraction of seconds. How does that work on a structure? Let me just show you. First, when you start a command, there are these dialogues before you can actually model. In the global UI settings, if you have this preference, you can also bypass the input dialog every time, because most often you would just be able to model, and if wanted, you can change the parameters of inputted things later. So now you can see that I use the marking menu instead. I'm able to create these three beams. When created, I'm able to mirror them on the other side. Now I can select all, and by multi-copy, again run from the marking menu, I'm able to quickly create copies of this structure. Next, let's put some purlins there. So again, I ran the marking menu, but this time I want to change the cross section and perhaps also the layer. So I'm able to do that during the inputting of the command by means of the properties panel. Again, let's use some multi-copy on this, and yeah, I want also to put some bracings on the structure. Of course, again, I can change the cross section and layers or all the aspects of the bracings. Again, multi-copy to put it to the whole part of the frame hole. Yeah, again, mirror. I can now yeah, select this. Let's select this whole part and run the multi-copy again. You can really see that after just a few usages, or after few times of using it, it feels so natural and so fast. I'm also able to create the most basic objects like load panels or 2D members solely by using the marking menu. And yeah, of course, I can also apply load for this let's say this simplified model. Yeah, I need to change. Let's change the value also. So there is some load on the roof. If I select the bottom points, I'm able to add supports, and if I select all the bracings, for example, I'm able to add hinges on all of them. So this is everything that I wanted, that I actually did only by using the marking menu. And as fluent as it feels, you also can imagine that I actually didn't move even my eyes from the, yeah, with the exception of working with the properties, but I haven't moved my eyes out of the model. I didn't need to search for commands in any toolbars, and the marking menu, the invisible helper, was there right where I needed it. Furthermore, to extend the possibilities of the SCIA Engineer version 21.1 regarding the new user interface, we have the input and results table. And these tables are standard. Most of you can know them from the old UI. and they allow specific workflows or specific tasks to complete by using them. You can have flexibility in modeling or editing the table. You are able to copy or paste data in there, and the table results allow you to show detailed checks. There are also some filters, and vast majority of structural components used in SCIA Engineer are supported. So furthermore, to actually having the table input and table results, we also increase the flexibility of the user interface. So all the components that are rectangular in shape, so it also applies to properties or the input panel, can be now just placed out of the application or another screen if you feel that's where you want those components to be. And these components will then be there consistently when you restart the application or do until you actually place them back into the SCIA Engineer canvas. We also redesigned the preview to look and feel like the new UI. And let me show you how that works. So let's start with the table results. So let me run some check here on my small building structure. I will run a concrete check of capacity. After just few seconds, the checks is shown, and right from here I can run the results table. This table contains all the data generated by the check, and in very simple way I can just sort the values. If I double click on any line, check will be shown in a preview window. This is a standard short way, but I can also run the detailed check, which shows all the formulas. And there is much more in this check, like the interaction diagrams and other information necessary. As I mentioned, I can seamlessly move these components just like that on the other screen. Yeah, I have just single screen showing here to you, so I just move it out. But this works in a very general way. Let me close the preview now because I can always open it again. By using control and clicking, I'm actually selecting the members. So this is possible, and when I selected these members because they were the most utilized, I can just by hiding unselected hide everything else, and I see only these two columns. Let's also have a look at results in table input. These three components are accessible from the menu under tools. So the table input, as the name implies, contains all different kind of input values, from structural related to loads or to libraries like layers or cross sections or materials. So you can see all the data in the clear tabular form. I'm able by using table input also to edit some values, because here I have quite a high amount of nodes, but I selected only 3. And if I go to nodes with the filter applies, I can see the values only on these 3 nodes that I have selected. By assigning different value, I can change the nodes right away, and the structure reacts to that. If I extend my selection, you can see that the input table dynamically changes. I'm able to resize columns or move them around, disable or enable them, and more importantly, I'm able to interact with Excel by just means of Control C and Control V. So if I just select all and copy it, I'm able to use Excel in order to place this data. This works the other way around too. If you have something created in your Excel, you are able to use table input in order to create things. Let's say here I have a parametric building written in Excel. I can just copy the whole columns and input them to SCIA Engineer by Control C and Control V. I can further create some beams, and yeah, this is only filling the dark fields, the required fields. Everything else is created as default. So I created nodes, 1D and 2D members. I can also create openings, for example, on this structure, and just by placing Ctrl V, the openings are there too. Now you can see how the structure looks. So this was really done in just a couple of seconds by using the table input. And so the possibilities are, I would say, endless. You can do basically anything you can imagine being scripted in Excel, you can create. And if you change the parameters just by replacing the values, you can see that the structure automatically changed. If I here changed in the Excel the parameter alpha, which is describing the angular difference between stories. So that seems easy, right? So those were parts regarding to the graphical interface and the components and what we allow. Let's have a look also at the concrete design, because there are some interesting features that were developed for this version. One of the most important, I feel, is, and it's very much also linked with results, is the reinforcement design on integration member. So since a few years ago, we are allowing you to integrate internal forces on integration member. And integration members can really be used on areas that would be nice to be checked as regular beams or columns, but from the global perspective of the model are better to be designed as a 2D elements. A typical example is let's say the lintels above openings. So you have here on the right side on the image, you have area above the window where lintels would be placed. You can calculate and design the reinforcement in these areas. There are also deep beams like the one connecting these two slabs. So there are on this floor there are slabs in different levels connected by a vertical wall, but it's not really a wall if it's half a meter high. So this was usually very challenging to model and to design, and to it the integration member, this can be done really in a very simple way. So very similarly to for shear walls or some slab or wall strips, like you can see in some cases on the image on the right side. Let's have a look how that works or how simple it is. So first you need to create the integration member and assign a cross-section to it. That's mandatory because the cross-section is then taken by the check. So you can quickly create integration member over this high beam. There is some opening in between. So yeah, let's skip the opening by designing only the part at the bottom. And by running overall design in the concrete with some, let's say, provided reinforcement defaults, the SCIA engineer will perform the design of these beams. And yeah, you can of course here choose difference in cross section. But when I run, yeah, I needed to check the default setting for both the high and the more shallow beam. But now when this is done, I'm able to run the design, and I get the required areas of reinforcement per each side of the beam. From these, I'm able to basically turn them into real bars by using the conversion to real bars. So yeah, now I'm not just showing it in the terms of area, but by the real bars. It is converted, and now you see that the integration member is really reinforced. To prove that this is actually working, I'm able to run a check on these beams, and after just a few seconds you can see that these beams are okay because the reinforcement was sufficient. It's not only tabular outcome that you can get out of it, it's also in form of preview, which you can use in the engineering report or printed outputs of your models. Furthermore, in the concrete design, it is now possible to design reinforcement in multiple layers. So this is very useful when long beams would be required by the structure, and these beams very often would require multiple layers of reinforcement, for example at the bottom side. This is now possible in SCIA Engineer without any difficulty to use on various types of cross sections. Let's now switch from concrete to metal and to steel, and let me demonstrate for you what we have what we have created for IDEA Connection, which is the new linking in version 21.1. So Ideastatica Connection is quite popular software, and we cooperate with their solution so that you can actually create your models in SCIA Engineer, and you can use the Ideastatica connection in order to check the connections without having to manually transfer the data of the structure and the data of the loading from SCIA Engineer to Ideastatica Connection. Let's see how that looks. So in SCIA Engineer you can run the Ideastatica command, and a specific window with checkbot will open, and the checkbot is responsible of transferring the topology and loading. So now you can just select beams and in the structure with results calculated. The checkbot recognizes these beams, and he creates Ideastatica connection project filled by this. When the connection is checked, it can be also checked by Ideastatica member. So not only connection, but you can click on another connection and have this one evaluated as well. So it's very simple. You just select a node that you want to check, and the Ideastatica connection project is created and pre-filled with all the necessary information that are transported from SCIA Engineer. Continuing on the metal side, this is actually something in between concrete and metal, as we have the possibility of checking a composite column. A composite column is by definition a combination of a typically steel rolled profile and a concrete. So it can be either tube filled with concrete or concrete section with I or H beam, and in SCIA Engineer this is now available in 64-bit version, and it was also improved because now this check actually allows to see detailed output with formulas, check different validity of the design, and also to exactly calculate the interaction curve for such a column. How does that work? Under the composite workstation, you can find a composite setting which contain the composite column as well as composite beam. And here you have the defaults from the standard that you can of course override if you feel confident enough, but you can just use the standard. And if you run the composite column check, all the columns or selected amount of columns are checked, and both tabular and graphical representation of the result is shown. Again, as I mentioned, the output is improved so that if you want to dive deep into the calculation, you can find the output in the formula layout where every calculation is neatly documented. Okay, and that's it for the features that I wanted to share with you. Let me recap and let me invite you to a separate webinars that we plan. So for the analysis and results improvements, we talked about 2D thicknesses, cables and connection forces. For user interface improvements, there is a table input and results, marking menu, and freedom in operation of the components. In the composite and steel topics, we have the composite column check and IDEA connection and IDEA member link. And for the concrete, we have the design and check of integration members and more layers of reinforcement. For the analysis part, a webinar is planned of 9th of November. And there we are going to get in more details about the topics that I just highlighted here. For the composite, the webinar is going to be on 2nd of November for IDEA link and other similar topics regarding BIM webinar on 10th of November. And for concrete, there is going to be a dedicated webinar on 4th of November. So thank you very much for your attention. I hope that the webinar was helpful for you and that you find inspiration and eagerness to try the new version and to really benefit from the new developments on both term of functionality and productivity. And with this, thank you very much and have a great weekend.